This call is now being recorded.
Okay. So first we will be starting with the single phase. So the in the single phase, the formula that you have to know about is first is regarding your base current. Okay. So you already know that this formula you already know P equal to voltage into current. Okay. So from this formula, you will be getting the base current. So generally, the base current is will be in terms of kiloamps. So kiloamps will be equal to base MVA, that is your apparent power, divided by the line voltage. So this will be basically your line voltage. Okay, this is for the single phase system. So in case of the per unit, if you want to find the per unit, as we have seen, the formula for the per unit is actual value divided by your base value. Okay, so for that at initially they will be giving out your actual value. It is you who have to find the base value. So not to find the base impedance, not to find the base impedance. Okay, so how you can find the base impedance is that it is can be found by base kV by base Ka, that is voltage by current. So this is similar to your Ohm's law. Okay, V equal to I into R. So if you are in need of your R resistance means what happens? You'll be having R equal to V by I. Okay, this is a formula that is find your base kV by base in the form of your and your power means. How we can find out means you have to divide this first equation. Okay, you have to substitute this first equation in the second equation. Okay, substituting in the first equation, the second equation means so students, I'm having some connectivity issue. Just wait a minute. So I hope the window is visible. Okay. So I had a compute issue. Okay, we'll be getting into it. So here for the single phase, so your base impedance is, this is the main formula. So base kV the whole square divided by base MVA. So with this formula, it is possible to find your per unit impedance. Okay, your per unit impedance is actual impedance by base impedance. So you'll be knowing about the actual impedance in the given problem, and you have to find your base impedance using this equation. Okay, so now coming to the three-phase system. So in a three-phase system, it is base, that is for the current, the base current in three phase is represented by your apparent power base MVA in three phase divided by base KVL. This is in your three phase. Okay, the entire thing is represented in your three phase quantity. Okay, so now coming to the you under a balance condition, if you want to find the base value for a single phase. Okay, so this is the confusion which was arranged yesterday. So if you want to find for the single phase in the sense, so this formula is base MVA by 3, you have to divide by the quantity of 3, but in case of your line voltage, you will be divided by root 3. So this 3 and this root 3 will be get cancelled, and the base current for single phase will be base MVA for 3 phase divided by root 3 into base uh, line voltage. Okay, so this is what with respect to your three phase system. Okay, so next we will be moving to the transformers. If they are asking to find with respect to your transformer in the sense, so the third one is with respect to your transformer. So in the transformer, as I said, there will be of two conditions. The base KV will be represented either in primary side will be either represented in your primary side or your secondary side. Okay, but while finding the per unit impedance, okay, this will be the same. The per unit impedance value will be the same for both primary and secondary side. Okay, so this you have to keep in your mind. So the next one is, as I said, the transformer will be represented in star and delta configuration. Okay, star and delta configuration. If it is represented in your delta configuration, then your base voltage will be equal to your base, that is base line voltage will be equal to your base phase voltage. So this is the basic condition, this you already know. That is in the delta connection, your line voltage will be equal to your phase voltage. But in case of your star configuration, your base line voltage will be root 3 times your base phase voltage. Okay, so this is the main difference. The next one is yesterday we have seen formula. Okay, the formula for impedance value. Now to find the new impedance value of the element. So that formula contributed is, I'll be writing it. I'll be writing the formula. Before that, I'll be writing the heading. So we are going to find the new impedance. So the formula was Z per unit mu equal to Z per unit given into base MVA nu by base MVA given, okay, given into base kV given by base kV nu. So this will be squared. Okay, so this is a basic formula, and now we will be seeing how we got this Z per unit nu. Okay, how we ended up in this formula we'll be seeing. So for this, first you have to consider your normal equation Z per unit given for a given quantity. The per unit will be usually represented in actual impedance divided by the base impedance okay, actual by base impedance, and after this base value you know how to find it. So base impedance is equal to the previous formula what we have seen. In case of your single phase and your three phase, it is base kV, it will be line to line, the whole square divided by base MVA. So from this you have to substitute this equation over here, and you will be getting Z per unit given will be equal to Z actual divided by base kV given the whole square divided by, that is, this is a KVLL, so this will be given divided by your base MVA. It's nothing but you are just replacing the base impedance with this equation. Okay, and now a common base value will be given. As I said, in the problem you have to select for your common base value, and based upon this common base value you will be, that is, this common base value will be taken as a reference. So upon this common base value you will be normalizing all the other equipments, right? So you will be normalizing all the other equipments. For this, okay, for this what happens if you are normalizing in such a condition means generally your Z per unit okay, so your Z per unit given will be equal to Z actual divided by base kV, but we are normalizing with respect to the base value, selected base value. So after normalizing, this will become for the given new voltage. Okay, after normalizing, this becomes your new voltage divided by base MVA. And you can take this as a fifth equation, and you can take this as your fourth equation. And here it will be new. Here it will be new because it is a new value. And now if you are dividing your fifth equation by your fourth equation, so you will be getting Z per unit new by Z per unit given, it will be equal to just dividing, so you will be getting as base MVA new divided by base MVA given. This based upon the new value into base kV given divided by base kV new. So this will be whole square. Okay. So now if you are taking this term over this side, means you will be getting this formula. You will be getting this formula. Okay. So your Z per new will be equal to Z per unit given into base MVA new by base MVA given into base kV given by base kV new. Okay, that's how it is. You just refresh these four categories of formulas afterwards. Okay, so now we'll be getting into the problems. So first we will be starting the small problem, so it will be very easy for you to understand. The first one is generator. You just take down the problem, and side by side you are also going to solve this problem. Okay, so take a note of it. So a generator is rated at 30 MVA. It's rated at 30 MVA at 11 kV. Okay, which has a reactance of 20%. So calculate its per unit reactance for a common base of, yeah, they are giving the base value as 50 MVA and 10 kV. Okay, so we'll be getting into the solution. The problem is a generator is rated at 30 kV, 30 MVA at 11 kV. It has a reactance of 20 percentage. We have to calculate its per unit reactance, that is Z per unit, for a common base value. They are given you the base value. So first you can write the given. What they have given, base MVA given, it is given, which is of 30 MVA. Okay, next one is base kV given, which is of 11 kV. After that, base MVA new they have given. So the common base value will be generally your new value. You have considered it to be your new value. So it is of 50 MVA, and then base kV new, which is equal to 10 kV. Also, they have given reactance of 20%. So the reactance of 20% represents Z per unit given. Okay, Z per unit given of 0.2 they have given. Okay, so they have asked to find what they have asked to find. They have asked to find Z per unit new. Okay, so now you just use the formula and find the Z per unit new. So the formula is Z per unit new will be equal to Z per unit given.
Sir, they are given only reactance value now, sir.
Yes, man. So the reactance is the given reactance value. So it is the 20%, right? So that you have to consider to be a given value. That is, this value you have to consider. This value you have to
Then
consider.
we should use X only now, sir, reactance.
No, actually we are talking about. Actually, we are saying here they have given reactance, but what you have to, how you can differentiate is that here they have given in terms of percentage. You have to see that. Okay, you have to see what kind of unit they're representing your reactance. Okay, so here they have given in terms of percentage. So generally you will be taking this to be your Z per unit given. Okay, if they are giving in terms of ohm, in the sense you have to consider that to be you have to use some other formula, that is your actual by base, that formula you have to use. And for this the formula is this formula only will be considering Z per unit new. I'll be writing it Z per unit given by base MVA, because here they are represented in the percentage. Okay, so divided by base MVA given into base kV new divided by base kV given. So you just substitute in the formula and give me the answer. You just substitute in the formula. So that's the value for your Z unit given. That's the value for your Z, base MVA new. Base MVA given is there. Base KV new is there. Base KV given is there. You just directly substitute it.
So
And,
it's base KV given divided by base KV new only, no, sir.
Base KV. Yeah. It's base KV given divided by base KV new. Okay, fine. So directly substitute it and tell me the answer. It's simple. So maybe just substituting. So it is 0.2 right into base MVA new. New is 50 and the given is 30 into, so given is 11. Okay, so here it is MVA, right? So MVA, so get cancelled out. Okay, and KV new, it is 10 the whole square. So we'll be getting the answer as, so what's the answer? So you might have calculated, right? So what's the answer
So
you are getting?
0.403.
Yeah, right. So it is 0.4033 per unit. Okay. So generally, how you have to represent this Z per unit new means you will be representing by putting a J before it. Okay. You'll be putting a J before it. So this is your answer with respect to it. Okay. So in this J will be, where you're putting means while representing your reactance or your impedance diagram, you'll be putting this J. Okay, so in the final answer also you have to put a J before the value that you have got. So this is what with respect to this problem. And next we'll be moving to the second one. So transmission line has as as impedance of, okay, as key, as the question raised, so here they have given the impedance value to be in ohm. Okay, they have given the value to be in ohm. So if they're giving in the ohm means what kind of formula we are going to use, that we'll be seeing. So the base MVA, so the base MVA is 100. Okay, base KV is 110. To find per unit reactance, it is Z per unit. Okay, so from this formula, first you have to write the given data. So given, what they have given, First thing is they have given your impedance to be 50 ohm. Okay, they have given your impedance to be 50 ohm, and this is nothing but your actual impedance. So your actual impedance value is 50 ohm. Okay. So the second thing what I have given is that they have given your base kV. It is given. So base kV given is around here. The question it is MVA. It is MVA. Okay. So base kV given is 110 kV. Okay, and base MVA given is 100 MVA. Okay, to find Z per unit. Okay, so the formula used here is solution. Formula used here is Z per unit is equal to actual impedance by base impedance. So you don't know the value of the base impedance, so then you have to find it. Your base impedance will be equal to, the formula is base kV given the whole square divided by base MVA. Okay, so at first we have to find the base impedance value, and after finding the base impedance value you just put it in your base, that is Z per unit formula, and then you find the Z per unit. You just do the calculation and tell me the answer. I'll be giving 5 minutes, so you just take your time and just simple substitution methods. You just try it using the calculator and tell me the value of the Z per unit. First you find the base impedance value, after that you substitute in the Z per unit formula. Okay, fine. So the answer is some might have arrived on it. Okay, so for the base impedance, so we'll be putting as 110 square divided by 100. Okay, so you can keep it as 11 square by 10. Okay, you just keep it like that and substituting here Z per unit. So in substituting Z per unit, you'll be getting 50 divided by 11 square into 10. So finally your Z per unit will be equal to J 0.4132 per unit. Okay. So I'll be giving the third problem. So you just try it on your own. Okay, we'll be seeing in the Monday's class, but you try it on yourself. Okay, it'll be somewhat based upon the first problem. Okay, just take down the question. Two generators rated at 10 MVA, rated at 10 MVA, 13.2 kV, and 15 MVA, 13.2 kV are connected in parallel to a bus bar. Okay, they feed so they feed supply. So they feed supply to two motors of two motors they are supplying of input 8 MVA and 12 MVA respectively. The operating voltage of motor is 12.5 kV. So assume base quantities as 50 MVA, 13.8 kV. Okay, so what they're asking to find is draw the reactance diagram. Okay, another one parameter they have given, the percentage of reactants for generator is 15% and motor is 20%. Okay, so this is the problem. So with this you have to draw the single line diagram. Okay, so after drawing the single line diagram, you just find each thing. So if possible, you just try this problem on yourself. It's very easy problem. So there are two buses, okay. In one particular bus, two generators are connected, and another particular bus, two motors are connected. So, and for all the representation of a per unit, you will be using the this formula. This formula with respect to percentile we will be using. Okay, this formula will be using for all the electrical equipments. That is for both the generators as well as for both the motors will be using. And finally, after finishing it, you have to draw the reactance diagram. So it is more or less similar to the first problem, but the difference is that you have to find it for separate machines. Okay, and they have given all the values, common base value also they have given. You just try this problem on yourself. Okay, so Monday tell me the answer. Okay, so totally I need 4 values for generator 1, generator 2, motor 1 and motor 2. In case if you are having any doubts, you just keep it for Monday's class. So I'll be solving the problem again. Okay, okay, is it clear?